I'll talk a little bit about recognizing kids' speech. My name is Abeer Alwan. I'm a professor at UCLA in electrical and computer engineering, and I have a lab there called speech processing and auditory perception. So my stand on my research, you have to have a hybrid approach. Data driven by itself doesn't necessarily always lead to the correct results because, especially in speech, there's a huge degree of variability. The same person, when they're depressed, when they have a cold, they talk differently. Men differ, women differ, everybody, there's a huge sense of degree of variability. Some of it can be captured by data, but some of it is actually comes from knowledge. Some knowledge about the language structure, the age, gender, etc. So in all my projects, that's my theme, is how do we actually do a hybrid approach to recognition. So what's difficult about kids' speech, and Chad talked about that. First of all, there is a lack of large databases, that's number one. But there's also significant intra and inter speaker variability. So if you compare the variability in the acoustic signal of kids versus adults, there's much more variability in kids. And that's especially the case until they hit about the age of puberty. 10 to 12, their speech could be treated more like adult speech, but before that, it's evolving and it's different. There's also significant variability in pronunciation due to different linguistic backgrounds and also due to misarticulation. In LA, 80% of our public school kids are of Hispanic background. And when I say Hispanic, it really encompasses a very wide variety of languages, not just, and countries. And so we especially have this issue. And also the misarticulations, regardless of the linguistic backgrounds, just kids are very variable in how they speak. There's the noise issue in the classroom. And one of the most fascinating things to me, because of a project we worked on, is how do you distinguish a reading error from a pronunciation error? You would think that it's really easy for, if you present a word to a kid and say, read it, and you should know what's right and what's wrong. And that's the project we did some years ago. It turns out even that is not that easy, because in Spanish, if you present the word van or ban, they are pronounced the same way because there is no VB distinction in Spanish. And so we thought, okay, we'll score the word according to what the teachers tell us. There must be a golden standard. So we went back to the teachers, and believe it or not, 50% said I would consider the van ban a reading error, and 50% considered a pronunciation error, because van and ban are two different words. So even at the word level, there could be issues which you do not, which could be complicated. So we ended up developing a system without feedback to the kid. We just give the data to the teacher, and based on their training and their assumptions, they would treat it either an error or not. And there's other issues. One, there's more omissions, substitutions, and mispronunciation, shorter words that make discrimination more difficult. There's more creative word use, like Chad was talking about, diversity in anatomy, and larger frequency and time domain things, and larger number of disfluencies, so ums and ahs and like and repeating the word. You ask them to say something and then they'll just say it 3 times for no obvious reason. This is just a picture just to show you the difference between adult and kid speech. This is just the vowel oo, and on the left, these are called spectrograms, so they're time frequency representations, and the dots represent the resonant frequencies of when you talk, what the resonances are. And so for males, you can see for this particular male, it's like 500, 1500, 2500, and 3000. And for an 8-year-old boy saying the same word, it looks very different. So if you're a machine and you're doing pattern matching, there's no way you can tell these two things are the same. Yet we as humans, when we hear an 8-year-old boy saying oo, when we hear an adult saying oo, we know it's the same. Because in our head, at least I think, we normalize with respect to the age, and therefore we do a different kind of processing. But that's one of the issues, that it's so hard. You can't use the adult databases easily to translate to kid speech. It's because it's not even a linear transformation. It's more complicated than that. And this is a picture from Cynthia's group where they tested very state-of-the-art ASR techniques for kids. And these, I believe, were 4 to 7 years old. And the error rate is noted. The orange one is for the kids, the black one's for the adults. And so you can see for the adults, the lowest one was about 7% error rate, which is great, but for the kids, the lowest one was 50%. So there's a huge difference, especially for this young population before, as I said, before puberty. So it's an issue, but it's not discussed a whole lot because companies don't say it. They don't come out and acknowledge that there is an issue, unfortunately. And that's what's been hindering, in part, the research, because then they act as reviewers to NSF, and when they see a proposal, they say, oh, but this is a solved issue. And that's exactly what happened to us 10 years ago. We did have a project back in the early 2000s, a great project, collaboration between UCLA, USC, and Berkeley, and we worked with several schools in the Bay Area and Southern California. And again, we went into this thinking it's going to be an easy task, it's just a reading task, and we know how to deal with noise because my lab deals a lot with noisy situations. And so we developed a component system where it presents.
Please read this word.
So, there's some not cute interface, and they will ask the kid to say the word, or so a lot of thought went into how to design the interface, what colors, what figures to use, and then we would collect the data, measure the decoding skills, score and analyze responses. We worked with computer scientists who specialize in databases, and we did a query-based data mining. So we'll ask, let's say we assess the kids 3 times a year, and then we could query the database and say, how did this kid do in September versus spring, for example, and see the progress. We can also ask questions, did the kids improved, who improved most? And then the other part of it was a display for the teacher to combine data to make decisions, because what they were doing, they were assessing kids 3 times a year on a piece of paper with 10 to 20 words, and we wanted to partially automate that. That's how we started, and give that information to the teachers. So as a resource for teacher development, we were working with the School of Education at UCLA to build that. So the things we were interested in assessing is phonemic awareness, word recognition, oral reading comprehension, and syntax. And the education folks developed a hierarchical approach to this. And so they said, first we'll drill down, we'll start from letter to sound, or rapid naming. And if they do well, we'll go on to the next stage, which is high frequency words. And if they do well in that, we'll move on to reading comprehension and short sentences, and then oral reading, and so forth. And so this framework, it was a really nice framework because it developed a certain approach, or you could go backwards. You can start with a sentence. If they can't read the sentence well, you'll drill down to the next level, which are individual words. They can't do that well, you drill down to the phoneme. So it was a really, this was from David Pearson at Berkeley, who was the dean there at the time. And anyway, so they developed that for kindergartners and also first and second grade, because that age is where it's really critical to develop good reading skills. And so compared to kindergarten, just the word list was different and the task was slightly different. And we would generate something like this. So the kid either said it wrong or said it right, and what's the, how quickly, what's the reaction time? And we will give that information to the teachers. But again, we ended up not necessarily color coding it like this, but actually for situations where the pronunciation, as I said, vam vam, could be acceptable by some teachers, not others, we would provide them with the data, and then they'll decide how they would score it. Another thing that came up, especially for the language learn, well, not really language learning, they just had different linguistic backgrounds. So they're kids of immigrants who have been there anywhere between a few months and a few years, and how that influenced even the reading skills. So some things we came up with or hypothesized is that there is transfer from your original language to the new language that you're acquiring, or if you're bilingual, to the second language. And you map, if there's a sound that's not in your original language, you will map to the closest one. So, for example, our kids were confusing V and F because that distinction, again, wasn't there for many of the Hispanic speakers. So instead of very, they would say fairy. And there's also the voicing between Z and S. Instead of those, they would say those. So all these things, which clearly the system could label as incorrect, really came from those kinds of differences in their original language. And just a little anecdote, I think I told some of you at lunch. One time I was at a conference, and next to me was sitting a guy of Asian descent, and he said, you know, his parents, I think, were from Korea. He grew up in Atlanta, and then he moved to Boston. And in Boston, because he had this interesting mix of, you know, the Korean background and Southern effect, then he was labeled in the Boston schools as a kid with reading difficulties, even though it was really his accent. So he was on a track for kids like that, and that actually motivated him to become a researcher in education and so forth. So actually, it was really interesting. So actually, this issue of accent is a big one, and it has implications. The problem is, even if you tell the teacher, so we ended up, you know, explaining all this to the teachers, they didn't know what to do with it, you know. So a big part of this has to tie back to professional development and sort of, I like the idea, somebody was talking about human in the loop. I think that's really critical for things like this because, you know, it's a two-way street. I mean, we were helping the teachers sort of understand, you know, these things about accent, and they were helping us in terms of how they see the scoring and how does it fit with the bigger educational context. So I think these technologies work best if you know, they're developed hand in hand with people who work in the field, experts, but also they can serve as a professional development tool if they do it well. I mean, my analogy, because I used to work with doctors before, so we would try to develop automated systems as a first pass. You know, like how you go to the eye doctor and the first pass is automatic by the machine and the second pass is by the doctor. They go in and examine. And I think this is where we're at too. I think maybe, you know, if it does really well, it could be like the first pass for screening or assessment, and the second pass would be refined by the education people. So when you're building a speech recognition system, you have to tell the system what are the acceptable pronunciations. And so again, you know, back in the 80s when AT&T had first developed a speech recognition system, it didn't work in the South when they first deployed it because all their training was done in the Northeast. And so they had to go back and re-record and get the pronunciations that you find in the South to put it in the dictionary. So the same thing here, when we're building a pronunciation dictionary for kids, we have to take into account all the possible variations due to the first language or due to them being kids. I mean, those are two different things. And so in our case, for example, we had, these are examples. So they would insert, like instead of saying station, say is station. So they had a vowel in the beginning. There's deletion, has is as, the H is dropped. And then substitutions, the vowel, cap and calf, and the vowel, you don't get it just right. So when you are building a system, you have to tell the system, these are the things you accept or not accept, and populate it with that kind of information. The other thing we were dealing with, because it was reading, is what we call orthographical knowledge transfer. So again, in Spanish, if you have J-O-S-E, is Jose. So some kids, if you see the word like joint, they would say joint. And again, that's not because they're not reading it, that's how they do the transfer in there, right? So there is the orthographic transfer, and then there is the pronunciation issue, and it needs to be studied. And so we thought we will find books on the subject from practitioners or linguists who tell us these kinds of mappings. It turns out there wasn't really. There's more anecdotal evidence by second language teachers, what they report in their classroom. So we had to, the student who worked with us had to dig back all these books, you know, from years ago and see what are the different anecdotes about how Spanish, or what's the accent for somebody with a Hispanic background. And then we looked at the data that we have, and we built a confusion or a matrix or a table for mispronunciation. So what you're seeing here are sounds. The pink ones are predicted from the hypothesis. This is what the books tell us, that most likely, if you have a Spanish accent, this is what you see. The purple ones is what we found in the database, which were not predicted from these other techniques. And it could be partially because it's related to kids. So for example, the first pink one on the left is pronounced as D, 30% of the time. So 30% of the time, the pronunciation of the was there from the database. Another one is, a common one was Z. Z became S. So those 70% of the kids in our database did that kind. So again, this again points to the issue that you really need both. You need the statistics, but you also need to put in whatever, statistics might miss some aspect that's not in the database, and that's where you would go back to linguistics or other fields to learn about this. So anyway, this is just a summary of the things that we saw. And so at the end, when we were building a dictionary, we had to, for example, if you have a simple word like can, we had to put in the native speech variants. So the natives in this case had two possible ways of saying it. Common reading mistakes, can, and then the Mexican Spanish accent in this particular one. So what are the lessons learned? Well, as I said, you need a human in the loop, at least when you're designing it, or an expert human, a golden standard. In our case, we didn't find a gold standard because the teachers didn't agree, but I think that's a different conversation. I hope that teachers will be paid better and will be able to be trained to deal with this large variety of possibilities of accents, at least in the reading domain. The feedback may or may not be reliable in terms of what the teacher is looking for. So you might think that the system scoring or prioritization is correct or incorrect, and the teacher might think otherwise. So you have to be careful about the feedback. And we find professional development is key, working hand in hand with a teacher. And we were lucky because we were working with the School of Education, and they would go out to these schools and work with the teachers and train them on these issues. And again, attention to ESL is critical and it is important. In the future, we are very fortunate to have a grant with Cynthia to look at building better interfaces for kids and collect data both for reading and story retelling and other tasks. Data is still very limited, so if you know of any, let us know. I'm personally very interested in longitudinal effects, meaning that as you grow, your mouth changes shape. And so you start really short and then it grows, and again, usually by puberty, both your pitch and your vocal type pretty much stabilize. So that means that if you had a toy which you're interacting with when you're 5, it may not understand you after a year or 2 because your speech changes. And again, that's something remarkable we humans do. We normalize, we hear these children growing up, and it's not like we can't recognize them at the same point. We just normalize. But for a machine, that's a really hard task. So one of the things I'm very interested in is collecting data in a longitudinal fashion. The same kid recorded over several years. We have a small database right now in Indiana with a collaborator. We only have 20 kids, but we record them twice a year over 3 years. And so at least for those 3, for that set of kids, we will have some information. But I think that's another important direction besides ESL longitudinal. I also think that, going back to some of the talks in the morning, the autism, I think it is a huge opportunity there to benefit, because they do, these kids, autistic kids, really benefit a lot from computer interaction for one reason or another, and I think that's a really great focus. I always tell my students the Edison example. When he invented the telephone, he was actually trying to help his parents, who are teachers of the deaf, and so he was trying to build a device that could help deaf children communicate, and one thing led to another, and the telephone was invented. So I also think that by focusing on situations where they are difficult and they break the system, that's a really good thing for everybody, because it just makes it more accessible. Thank you.